another frequency here or here or here, that's not being fed back in. And the one that gets fed back in is the one that reflects back and forth over and over and amplifies itself because of the amplification of stimulated emission. So that happens inside the laser here where the gain medium is, remember? So that's how, nu 1 wins out. And so nu 1 is the frequency, therefore, that, so now the question is that, of course, nu 1 will have some width, right? I mean, nothing is a delta function. So the question is that what determines the width of the lasing frequency nu 1, okay? And and this of course is the delta nu L, okay, the ultimate laser line width. Okay, and so the answer is that, so this is the question, and the answer is that the width of nu 1, that is delta nu L, determined by, what do you think that is? It's determined by the resolving power of the diffraction grating, meaning that how finely is it able to separate out the colors within this cone, right? Is determined by, so actually there are two things, by the resolving power of the diffraction grating, okay? So that's of course the 1200 lines or grooves per millimeter. How well do they separate out the different colors? How well are the different frequencies separated, within 2 times delta nu separated. So that's from the resolving power. The other thing is that the finite aperture of the lens also, because whatever is subtended by the lens, I mean all of that, when you adjust the grating, then whatever hits the lens gets to go back in. So the finite aperture of the lens plus laser diode output aperture, of this system also, because whatever's reflected into the LD will laze. Okay, so meaning what I'm trying to say here is that if this is your, if there's a lens like this, right, and then you're trying to feed back into this, then you notice that, so the cone, so the light comes out, and then there's the 0th order, right, but the -1 comes back in, and the -1 that comes back in, it may have, this and that, so that's nu minus delta nu, and this is nu plus delta nu, But you notice that, and these are being reflected back. But you notice that whatever fits into this, and this is all exaggerated, but whatever fits in here will all get to go back in. So the finite aperture, this size of the lens also determines that you can't just make it a delta function, okay? And so those are the things that, but you can get extreme narrowing in this way, down to, like I said, that with the diffraction grating, you can achieve 1 to 10 kilohertz delta nu L, which is plenty for extreme precision experiments. Okay?